out a full-fledged application with multiple activities, multiple services, things running in the background, making HTTP requests, and working with JSON, et cetera, et cetera. So I encourage you to, if you haven't showed up to section, which may not be any of you, but yeah, to do so this week. And then I will have office hours tomorrow from 11 to 12. As a reminder, I'm not going to be focusing too much on emulator problems. We spoke about this earlier in the first week that it was the programming assignment was announced. This week we'll just be focusing on actually implementation. So emulator issues need to go on Piazza.
Thank you. Also, did you want to mention that the design 3, okay. So basically, we released the grades, but mainly, more importantly, honestly, is the feedback. So hopefully, the groups all got feedback on some of their brainstorming and design selections. If you feel like you didn't get enough feedback and you want more, please, the sections and the office hours or my office hours are also a good point to come to that. I should also point out next Monday, sometimes we have folks that are definitely great speakers in HCI, and we have to have one of them coming next Monday. The talk is, I believe, 3 to 4. I'll just announce it, and I'll put more information on Piazza about it, basically. But you'll want to come to that, and you will learn even more from an expert about HCI.
Did you hit start?
Yeah, I got this. I think it's all running. Okay. Welcome back. Lunch, good, bad, ugly? Who had a hot lunch? Who had a cold lunch? Who had no lunch? Oh my gosh, okay, we're going. All right. So let me do a little bit more. We talked about design, we talked about color, we talked about typography, we talked about a lot of important aspects. I want to do something about Gestalt principles, and I also want to talk about how do you communicate visually, so kind of the way that you can do information visualization. So Gestalt is sort of this principle of a unified whole, and it's this kind of generates from German psychologists in the 20s who theorized that there's these kind of unifying principles that are compelling kind of for us to experience. And those are those things of regular and orderly and sort of symmetric and simple kind of constructs. And the Gestalt principles, and you'll see, I will explain them to you in this abstract sense, but then you'll immediately see how you are experiencing many of these everyday user interfaces. So these are a list of them, and I'm going to walk through them. Things like figure, ground, proximity. We'll walk through this list. So these are roughly the principles that are good design usually follows. One thing I realized, I had some interesting discussions at lunch with people. There are lots of times we talk about all of these ways that you can make choices to make things more usable, more approachable, easier to understand. But it's true that the reverse is also a useful technique. So we talked about how you might want to make something more difficult or harder if it's something that either you don't want someone to use, maybe deleting all their address book or something like that. Sometimes this is done like a company might want to discourage you from actually using a particular part of their interface, and so they can take these exact principles and invert them. So it's not that it's one way. Once you know them, you can kind of be on the dark side of the force with others. So figure and ground. So this is this idea of surroundness and how you can play with sort of either a figure or the background, and the way that we kind of perceive the background and the way you can actually generate people to infer what images are. So this is this classic example. I'm pretty sure most of you have seen it, but you can create things that are sort of ambiguous. You see two figures here, and you see a base, right? And as you push them away, you see more background. It becomes less ambiguous when you put it in these different cases. There's a way that you can play with figure and ground visually, and whether or not you want it to be ambiguous or not is up to you in terms of your design, but usually you want something to be not ambiguous, but you want to play with the idea of, are you kind of visualizing the figure or the ground? So here's some more specific examples where you've seen, this is just playing with some imagery, either a figure that's kind of coming out of the background. So here you kind of see a face, or you see these lines. Here you see like a tree or a river, but that's all suggested, right? It's not as if there's actually lines drawn for the tree. It's just that that's part of either figure or ground. So you can play with that. As humans, we start to see things as connected in that way. And this is another property of proximity, and it's pretty simple. It's that we see things that are together as group, and so we see them as group or connected, and when they're not, they're separate. This seems very obvious. You've seen this used in different kind of logos or ways for people to represent connectedness. So it's just playing with these kind of ideas of something being connected because they share some kind of relationship. So elements that are near each other will seem to be related. Now I'll just point out, we can go back to kind of some typography and graphic design and see that in play. Here's, for example, a menu. There's a date, happens to be election day, there's some information about the menu choices that's kind of laid out. So we can use this property of proximity to just pull things together that are related, and we will visually connect them due to the proximity. So all that's happened is the date and the fact it's election day are now pulled together, an American menu, and then we pull together visually these components that are the same, meaning they're menu items. So this is an example of just using proximity. Another principle, Gestalt principle, is this idea of similarity, and that is that we will view things that are similar as also connected. So the same shading, the same color, the same sort of hatch pattern. So, for example, all the sort of darker circles versus the gray circles, or if it's an X versus a circle, they're just similar things we visually feel that they should be tied together. And it's also just an example of sort of a picture where it's really a sun and I think it's kind of an eagle, perhaps. They're visually tied together because of this similar sort of arrangement of spikes or triangles around the side. So we draw them together. They don't actually feel like two separate objects. And just applying that again to that same example. So now we took some typography, we said, well, what if we use that same rule of similarity and have things that are similar have the same typography? So in this case, we pulled out either bold, or we could have chosen a different typeface or something like that. And the idea is this is easier to read and perceive and sort of also kind of parse through. So immediately you're starting to get a sense of how many items there are, and this is a menu, whereas, it takes you a lot longer, even in that first example, to understand what this even is. This is such a poorly designed menu. I'd be like, whoa, what's going on in the kitchen? I don't know if I want to eat here. Look at the typography choice, right? That's how you should choose your restaurant. Okay, other things that you can use as techniques to pull things together visually, and this applies again, not just these items, but the way you design interfaces, the way you might design your poster, things around symmetry. So bilateral symmetry gives a strong sense of a figure in terms of pulling things together. And also you can really pull things together through just literally putting connections. So connections, actually, when you connect things with a visual complete line or some other visual cue, that overrides everything else. So if you look, those in B, it's clear those are connected even though they're different colors. Or in C, where they're different size, or D, where they're different shapes. You still instantly, that seems to override all the other cues that are saying they're not connected. So sometimes if you want to draw dissimilar things together, you can use this connectedness rule. Another one is continuity. So this is the principle that, the contours based on smooth continuity prefer to abrupt changes in direction. And so when you look at something like A, you kind of imagine, we prefer these smooth, not abrupt changes in the way that that's kind of visualized. Similarly, we talked about how Connections that are clear with smooth contours, it's easier for people to often follow. It's even easier, there's a consistent gridding, which we saw in the subway maps for the London Underground. Or this is like a logo where there's some continuity of kind of motion through there. That's also some figure and ground kind of play. Another one is closure, and this is that we sort of imagine, when we visualize things, we see how they might be closed form, even though we don't literally close the form. And you can use this as a technique. So, for example, we see this as a circle behind a rectangle, not a broken circle, right? We don't think of it that way. We imagine that things are closed. And because you know people will infer that, things like all we've done is cut little edges, little cutouts for these circles, and you instantly can imagine that there's this square in the middle. So it's this illusion of different contours. Similarly, this is a logo around this panda, which is not complete, and you can use that to have people complete the closure. All right, so just in summary, this is more the stuff I didn't get to at the very end of the lecture, but roughly the design is about communication, form, and function we talked about. Things around simplicity and elegance are key parts of that design. We talked a lot about typography, things around size, weight, different choices around layout, ways to kind of mix and not overloading. It's always about less is more, so fewer selections for your typography, different fonts, fewer color choices, don't try to overrun things. We talked about, I made this funny reference to the salad, right? Just choose the 2 great ingredients and let the flavors come out, right? Small palette of colors. Human vision is often organized by these Gestalt principles, so you can use them. And you also can get trapped by them if you do things and people get tricked into thinking there should be some closure or some other thing. You have to be careful about that. And often a good mode to be safe is to use this grid layout. You can just lay out any kind of grid and just work with it. And I showed you some examples of how you can really explore that design space. Okay. So I think the slides will suddenly shrink for some reason because these are at a different aspect ratio. Oh, yeah, okay. All right, questions, because I want to go on and try to talk about more information visualization. Okay. So think about this for a minute. What is information? What are you trying to visualize? So this is the action or fact of visualizing, the power or process of forming a mental picture or vision of something that's not actually presented. So it's how to convey some information without kind of writing down what you're trying to convey in sort of script or letters. It's doing something with some visual elements and rendering it as visible. So let's just think about some examples. I'm going to ask you if you have some too. So here's a couple. So here's a visualization of, remember that happened last time? Yep. We wait and then we replug in. This is so bad. I know what I have to do. I have to power this. Yay. Okay, I probably totally knocked out for a minute. But this is a perfect stopping point because I wanted to see if people had some examples about this, power cycle, who knows. So visualizations, think about some visualization you saw today. So you saw briefly some pictures of things you might find, like there's an ear, kind of communicates information about what an inside of an ear is. But what's something new to make? You must have encountered some visualization today. What are some things you encountered today when you woke up to kind of your class, probably? Yeah.
I was playing with a map data set earlier that shows the gentrification of the Bay Area. Click on different areas in the Bay, and it shows you like by color, like status and level representation.
Okay, like a map. So a map about sort of gentrification of the Bay Area. Yeah, okay. So lots of things with spatial information. What else? Must be some other cool things. Did anyone check the weather ever? Was it given to you as just text or was it visual? Visual. Anyone thinking about earthquake data for any reason unrelated to this class? Well, what are the visual things that people see? Yeah.
I went to a bus stop and there was still people there. And then I concluded that the bus stop.
Oh, I like that one. Yeah. So a bunch of people standing at the bus stop, bus not coming, delayed or something, right? Okay. Yeah, just like visual information you extract from kind of everyday actions that people are doing. All right, see if we came back. Oh no, that's not even on. Whoa. Whoa. Where's that little remote? Last time I hit that remote, it came back. All right, pause while I tell them something. Hold on, sorry.
Yeah, that's why.
No, that.
I have this little question. Decided.
Yeah,
I don't have any. But I do have it.
So you do that reading?
Yeah, like that. Oh, that's why the ladder's there. Okay.
If you don't mind just
No, that's fine. Ladies and gentlemen, the next part of the act will feature Joey, who is trying out for some circus skills. He'll be going and climbing up to perform one of the stunts that we know as resetting of the projector.
a glass of water.
He needs silence to do this, everyone. It's very dangerous.
And I'll dive.
Do you want me to spot that?
Hello.
Let's hear applause, everyone! All right. Anyone else who wants extra credit can also climb up and reset it later. We'll get in trouble. Let's see. All right, so we should come back. Don't worry, we know about this problem. Remember I said our secret word for the semester? Experiment. So this is why we're experimenting. Okay, so can we just come back now that I plug in? Okay. This would be a perfect day. If I was Joe, I was going to hide some secret treasure up there, and then no one would know. Secret place. Actually, so there's a lot of things that are communicated to you visually, and it's not through text. And the point is that if it's done right, it can really be powerful. And you've seen different designs, but even take something as kind of mundane as just the weather. You've seen how people have done iconography. They now have people have done things with kind of imagery and photographs, trying to convey a sense of what the weather is. Some of them communicate it through what you should wear. Some of them talk about temperature. There's different ways to kind of visually think about it. Oh, it's flashing, which is a good sign. This will be very mysterious for anyone who watches the video later, because they'll be like, oh, here we go. All right. Thank you, Joey. Yay. Okay, we now return to your regularly scheduled design. Okay, so we talked about some of these things already, sort of spatial design, things with maps, colors. This was an interesting visualization. Does anyone know what this is? It was from about a year ago, a little over a year ago. Yes, look how thematic this is. This is showing basically there's a technology that was designed by Java that sort of tracks people's sleep patterns, and they instantly tell that all those people were awoken at the same point in the same geographic area. And lo and behold, that was right at the Napa earthquake in the middle of the night, a little over a year ago. So a cool way to visualize, like, you know, there's other data to extract and visualize. Wake up. Why do we create these visualizations? Well, one is to just record information to show things, but often we're trying to actually support some reasoning about what's happening or why something is happening, so we can position an argument about, you know, changing kind of behavior, all these different things. We can also persuade people and emphasize important aspects. So there's a lot of reasons why you might want to have information visualization. So if you think about recording information, these are sort of early drawings that were done by Galileo, when he was sort of trying to convey to people that the moon actually had these sort of ripples. It wasn't actually a perfect sphere. It actually had texture to it. It had terrain. Also to answer questions. So Muybridge basically looked at how you could convey information about if there was a kind of a hypothesis at the time that maybe it was unclear horses actually when they were running, if they had all of their feet off the ground at one time. And this was a visualization of that that shows that indeed they do. So it's very powerful. Rather than just textually explaining that, this visualization communicates that. Here's the next wearable project we'll be doing. Now, this is another recording instrument. Anyone want to guess what that is? There's some information to figure it out, but yeah. Yeah, that's recording pulse. This is the first, I guess, pre-wearable, whatever, Apple Watch, Android Wear, pulse communication tool. So it's a technology to actually look at your pulse, sort of amplify it mechanically, and then see how it's drawn there. Oh, that's how that works. So you can communicate things around the body. And like I said, it's also for supporting reasoning. So this is a good example of the cholera outbreak that occurred in London. And this is one of those sort of places to look for a lot of information visualization is Tufte. He's put out a number of books, and you can they're great kind of visual reads to learn about information visualization. I strongly think any kind of designer has these in their kind of tool bag of good design books. This is an example, he uses this in others, but the cholera outbreak and putting little dots where people had lived when they had contracted cholera. This is a sort of map of that. And by putting it on this map, and it sort of zoomed up here, there was this particular pump that was located where people were getting their water from, right there on Broad Street. And it's clear once you start to look at the data this way that maybe the people, maybe there's something wrong, or there's some contamination. In fact, that was the case, that pump on Broad Street was causing the sort of cholera outbreak. And another kind of disaster was more recently, the sort of Challenger, when the space shuttle broke apart in '86. And when they went to sort of look at the information, it was really confusing. Lots of different people referred to the rocket and the boosters by different terminology, different names, different ways to sort of discuss it. And it was not till sort of information visualization people got involved that they said, well, let's try to look at this differently. This was one visualization. By saying, let's look at the rocket booster manufacturer of the sort of amount of damage. This is sorted essentially by temperature. Okay, so you can kind of see what the issue is and where there's reverse damage, because they recover these when they come down. And this is another graph that shows that same kind of visualization, but now it's even more extreme. This is showing on the x-axis sort of temperature, and then the kind of amount of damage, and it's showing that clearly as you start to lower the temperature, these rockets are coming back with more and more damage. And the actual temperature at the launch time was way down here in this gray bar. And you can easily see that looks like it's probably a bad idea. We've never had a launch of these. We've never seen the performance of the O-rings in this condition. There's always been damage of increasing amount as we lower it. So it's a little bit of, Monday morning quarterbacking where you're looking back, but clearly you start to visualize the data and see what the actual cause was. Sometimes you just want to convey information to others, so things that you want to communicate. This was an early sort of visualization of that. So William Playfair, look, and he's the same one, he kind of invented pie charts and bar charts and things, and this was just a visualization of the essentially trade deficit. So if the balance against or balance in favor of England, and so when that crossover point was for import and exports. And sometimes you want to tell some story. So this is, you might start with a graph, not a graph, but just sort of a table of data. In this case, you're asking sort of what's the most powerful brain, and this is body weight and brain weight, and you're sort of correlating those across a bunch of different animals. And this is one visualization of that. So you can sort of start to see the body mass going up, and then the sort of brain mass, you can kind of see up in the corners, blue whale and a hummingbird. This is scattered. And there's a different way to think about this because you can actually relate the brain to the body mass in terms of the sort of body surface area. It's a little bit different. There's this kind of equation at the bottom that takes the brain weight and the body rate, sort of scales it, but you can really start to clean up the data and start to see something emerge that communicates kind of where, of course, things like, humans, dolphins, other kinds of higher mammals that have a lot of, have been shown to demonstrate a lot more brain capacity and kind of how that visualizes. That one picture tells a lot of story, but you wouldn't have to sort of explain that if you want to use that. So visuals, when they're done right, instantly communicate something. Now, I don't know, this is totally out of context, but imagine you're trying to tell that story. This would be a really powerful visualization for that. You can think about that when you're designing something, say you're doing an interface, you might think, at this point, I want the user to know whatever, maybe it's this earthquake was twice as powerful as the last one, or some other information about how far they are away from their destination, or how severe their flight is delayed. Or you might want to think about, how can I visualize that? You see this happens in a lot of interfaces now about timing and spatial relationships. And our friend Herb Simon, who visited us, I had a slide on the first class talking about design, I think, and this idea about everyone designs that sort of envisions these sort of states to desired states. And he talks about, well, what information consumes us is rather obvious. It consumes the attention of its recipients. Hence, a wealth of information creates a poverty of attention and a need to allocate that attention efficiently among the overabundance of information sources that might consume it. And this is, I mean, everybody gets this. Everything's competing for your attention. You know, alerts and Facebook, this and that, and you know, updates and every little thing that's coming at you. And he's sort of speaking some time ago, before a lot of the emergence of this, saying the design is really, we're consuming people's attention, and that comes at a cost. So as designers, we need to be very conscious of not consuming people's attention. And so even, you know, things like how long it takes for something to happen or how many alerts come up. And you probably noticed this, and maybe we hand up the watches, and for those of you that get to play around and have a smartwatch, it can become very comforting if you kind of get these prompts at just the right moment, but can also be extremely distracting when now there's yet another thing poking you and, you know, rubbing your wrist and doing things. So often we're dealing with some data that we want to visualize. And the point I want to make is when you are talking about or you're thinking about visualizing some data, you want to think about what kind of data that is. And there's a couple of different types. One is that there's some physical type, some, you know, characterized by some formats. We have, okay, we're used to as computer sciences, okay, we have their booleans or floats, things like that. Or something abstract. So these are a little bit harder. They're usually not ordered. They're much more abstract the way we talk about them. And in there, we can think about them as having these different sort of qualities. Nominal, so things that have just labels. So you see the example there, apple, oranges, pears, whatever. These are just, you know, lists of things. They don't have a hierarchy of, it's not clear that one goes before the other. They're distinct, okay? The other one is something that's ordered. So some grade A, double A, things like that, or something that's clearly ordered, you know, first class, second class, third class, something that has a clear ordering. And there's also these sort of more quantitative, so it's just real numbers or measured with sort of large distances or temperatures, things like that. So the reason why it's important to think about these when you're designing is if you have some data model, so something like actual numbers, so in that example, it's these sort of floats, or conceptual model about what temperature is, and also thinking about a data type, like is it verb or not verb? That would just be one or the other. It's not one, they're not ordered, they're just nominal. Or something that's ordered where you want to think about it as hot, warm, cold. Clearly kind of warm comes between hot and cold. Or some continuous range of values. And the reason why this is important is because there's been a number of individuals, Jacques Pertin actually studied these designs and figured out what visual elements work best for these different classifications of visualizations. So this is a picture which I mainly want you to focus on where it says just the points there. Go with the lines and areas for a minute because it gets a little confusing. But what he's saying is, if you have shapes and you want to communicate things with different shapes, that works well for sort of qualitative differences. And size, also similar. I'll show you an example of that. And down. So these are elements, if you were thinking about making a visualization, you can say, I'd like to play with shapes or sizes or color hue, color value, intensity, texture. So I'll show you examples, so hopefully it'll be more clear. So you can also encode information in a position. So if you look, here's A, B, C, and it's clear that B is between A and C, and BC is sort of twice as long as AB, roughly. And so we're sort of encoding this sort of quantitative variable. So one thing is because there's this order, we can encode things in space, and that's a really powerful notion, because you can start to play with distances and scaling and things like that. So what about encoding information in color and value? So value is perceived as ordered. So he did these studies, as others did, and you can encode sort of an ordinal variable. So you see, you know, this coloring has this sort of orderedness to it. But continuous variable is not as well. That's because humans are very bad at perceiving little subtle changes. So it's harder to encode something. They can't tell distance. It's hard to tell how much grayscale is between two locations. Hue is perceived as unordered. We don't really usually consider sort of, well, blue comes first, then red, then green. They're just considered distinct. Okay, so it's good for nominal variables, like the ones I was talking about with just bananas or apples or something that's kind of unordered. And he went through this whole kind of list, and he looked at all of these, and he said, well, for position, so imagine where you're positioning a visual element. He says, well, these work well for nominal, because if you position something that can, obviously it could be distinct, but you can also play with ordering, so the position can represent an ordering. And similarly with size and value, but things like texture, and particularly the ones I briefly mentioned about color doesn't have like an ordering, so you don't want to use something that's ordered with color. We don't have often an ordering with orientation. I mean, sometimes it could be like a clock, like, okay, maybe it starts here and sort of moves around, but normally there's not an orientation. And similarly, shapes, we don't perceive squares as coming before triangles or rectangles. So it is important to realize when you're doing design. Okay, so this is another example of that is it's hard for people to actually estimate magnitude. So for example, you know, which one of these is brighter? The screen, you might be able to pick it off because it's a little bit. Which one looks brighter there? Right, yeah, right one looks a little brighter. So close. So sometimes you can actually discern the difference, but often it's really hard, particularly on small screens, or if they're far apart, right? So people study this. This is the kind of just noticeable difference kind of equation, and it mainly references that sort of the ratio is more important than the magnitude. So the ratio in terms of the difference over the kind of range. So most continuous variations proceed in discrete steps. So it's easier to sort of perceive them and put them into these categories than to try to have people perceive them across the whole spectrum. And this is a really interesting study. We talked about visual perception, but this is a study looking at other kinds of senses and how people perceive things. So it ends up, not surprisingly, the sensation of shock is very easily perceived, whereas smell differences are harder for people to kind of decide on. So in some sense, you can usually sense like heaviness or taste, or you can see something's length, but in fact, some of these others might not be good choices because they're harder for people to actually tell the sensation differences, how the human body perceives these. And this is just a little bit more kind of mathematical about that, but it's interesting because it lets you think about other ways you might want to design a visualization. It might be something that actually is physically experienced as well. So you've seen how even the design of some of these, you know, vibration cues on phones and watches, they've said, well, let's try to look at how much can we embed as a mapping of data onto this. So vibration, there's sort of a range, and there's how short of a duration you can actually observe or measure or differentiate. So you want that to be clear, because if you can't tell if the vibration was, you know, I don't know, call home immediately or, you know, something more minor, that you need to be able to tell that. Oh, also I should mention, just switching something here, but the keep the design suggestions coming for things to critique in class, because we'll be going over those. Okay. Okay, this is the last little bit. I want to say something about, I want to say something about prototyping, because It relates to how you can communicate essentially a lot of these designs. So in terms of prototyping, we often know more than we can tell. And it's also this interesting thing about we can communicate and also surprise people if we do the designs right. We talked about this idea of sort of tacit knowledge about how people already know how to do most of their, you can watch how they perform, and people that are good at sports or drawing or other skills or instruments, they have this tacit knowledge, so you're trying to sort of tap into that. So in fact, there were studies about people who played Tetris, and they noticed, experts sort of played sort of differently. They were sort of the way they kind of perform the rotations. And so you can study how people perform and understand what tacit knowledge they're bringing into understanding the game. So when we're doing some prototyping, the question is, when and how should we construct prototypes? And generally, there's a couple different reasons. One is you might want to understand an existing experience. So you make something to sort of study some existing experience. So you did that a little bit with this early watch prototype. But more likely, you were inquiring actions. So you wanted to sort of go and study people's behavior with something. So one is to sort of start to ask questions. One is to actually sort of study them. But often, you also make prototypes to communicate your design to others. So you might go to a design team and show them these prototypes and start to actually communicate with them about the design. So to force them to kind of make decisions. I used to go, when I was at Intel, I'd often go into meetings with lots of prototypes because instantly people would start picking things up and looking at them, and there were a lot more questions before I even started talking. There was just a lot of excitement about what these are and what will be revealed about them. So in terms of understanding existing experiences, so this is an example of a prototype around a phone where you want to understand maybe how would someone use a phone in cold weather, so with a glove or some kind of other condition, or how would someone use it if they were performing some other action, or they were using a bicycle or pushing a stroller or whatever that is. And so you can often do this by actually prompting people. So there's this experiencing a train journey. So you just give someone a card and say, be hungry, try to find something to eat. You can give them these tasks literally like that, and you can watch what they do. So they start to ask people, they start to walk up and down the aisles, do they sort of imagine that they can, what do they imagine that what they would do to sort of achieve that task? So the other one is really this idea about you want to make it to kind of explore, experiment, or validate some design that you come up with. And really, this is from IDEO, they talk about it as these multiple stages of, you have a bunch of ideas, you're sort of in this stage where you're trying to inspire, and often you can use these prototypes. When we looked at that video several weeks ago back when we were at Sibley, we looked at how people really got inspired about all these different objects they had, and they're talking about the shopping cart design and other things. But then as it evolves, you're using these prototypes to actually then validate whether or not they're good designs. And you saw in that example, they brought the designs, the prototypes, to users, and they asked them what they thought of it, and they got feedback. So you get a chance to do that. And we saw this picture before of this prototype for an early phone, for an early camera from IDEO to sort of explore how you would interact with the camera. So that's an example, trying to understand how users would use different camera selections. And we saw this picture, I think, before of the original kind of iPhone and how you would sort of start to prototype that. And there were lots of sort of designs and sketches around just this particular product about how it would be thought of, how people would actually use it, hold it, what kinds of sketches. These are sort of different visualizations of people trying to look at the whole experience of design. These are more just speaking to the kind of industrial design aspect for sizing. They don't really represent it in use with someone's hands. This is another exploration of that, looking at prototypes for the Microsoft mouse. So really prototyping a lot of different designs, having people hold them and touch them, move them around, kind of live with them. Again, trying to get that sense of what people would desire or not desire and to speak about them. You can imagine if you didn't have these prototypes, people might say, unuseful information like, well, I just wish it was comfortable. I wish it was kind of like easy to move around. It's like, well, which one, what aspects? Is it about the curvature, the bevel, or the way the button feels, things like that. And then there's this idea of, like I mentioned, when you're trying to communicate or persuade people. Okay. And the thing that you got a chance to do earlier is really paper prototyping, but I want to talk something about this Wizard of Oz study. So this is, you know, you're paper prototyping little phones, a little phone with a little charger, a little phone, flip phone. Okay. What you really want is lots of materials. This should be in your kind of design arsenal, right? X-Acto knives. This is what this space is really going to help us do more of. We'll be able to actually prototype more things here because we have the space to spread out, cut, draw, glue. We had a good time doing the prototyping and the brainstorming during that time. You also want to work a lot with designing kind of physically what the screens look like. Often you'll lay out how you actually imagine each part of this interface. You'll do wireframes for that. And you'll actually make little elements. So in some of these paper prototypes, you can see this is an example of someone actually, you know, I don't know, here's some buttons. We'll just make little covers that check box, and we'll just move little sticky notes around for icons. So they're literally making a paper prototype. And then they do this thing, this Wizard of Oz testing. So this is actually, you guys remember the Wizard of Oz when, you know, there was the man behind the curtain driving things. And I alluded to this a couple lectures ago. This is a little bit more detail on that, of how you can sit down with someone if you've done all their kind of paper prototypes. And some of you did this on the very first assignment where you showed people a kind of watch interface, but you can imagine doing this with the screen or with any kind of design. It could be something on the body, it could be something on a tabletop, wherever you imagine it being. And you actually, you become the computer. So that's why I said this Wizard of Oz, that you're actually the person that's constructing it. So you will sort of set some deadline of how you're going to build this. You'll draw sort of if you're doing this for like a, say, a graphical user interface on a window, you draw some large screen, and then you'll put different regions on these sort of cards. And you often just put some, you know, sort of text about, because sometimes it's important what the text is, and of course you write that. And you gotta be ready to respond to any user action. So if they have a pull down menu they might want to do, and you can use photocopiers. Also now there's really great tools. I mean, Balsamic and other tools have a lot of this embedded in, so you can actually use that. And then you literally sit down and you become the computer. So this is the slide I hinted at from before. Someone is usually observing what's happening and kind of trying to document what's happening. And you are basically the computer, and as they say, okay, well now I want to pull up a particular menu, or they're clicking on something that you have to pull up the right card. So yes, it's slow, but you can easily go through windows. What happens if they do something you're not ready for? Well, you should have your Sharpies ready, because you probably have to draw something quickly. You can also kind of throw up an error message, right? So when you sit down to do this, you usually have someone that's sort of greeting the person, that's going to be getting the data, but also someone who is going to be giving them instructions, someone who's the computer, and someone that usually is just sort of taking the notes. That's usually the structure for setting this up. And typically, it depends on what the task is. It could last up to an hour, and also debriefing them afterwards about their entire experience using this. So you greet the person, you talk to them about how you're going to run the test. Next class, we talk about doing, getting sort of IRB approval, or kind of ways that you actually get them to sign off. You're allowed to kind of ensure them of the confidentiality of the experiment. You walk them through this test, they perform some simple tasks, and then often you'll hand them written tasks for the users to do, and they kind of work through your interface. An important part of this is doing this, what they call think aloud. So think aloud is basically where you're prompting them to do that. Think out loud about what they're doing. So it's hard, you have to kind of always prompt people to do this, because normally when you're interacting with most things, certainly a computer, you're not thinking out loud, but if someone who's doing that, so for example, if you said, you know, go and, you know, go find the email from yesterday about, you know, the school pickup or something. You go, okay, you have to tell them, like, what are you doing? Like, first I'm trying to find how to get out of, like, Keynote. Now I'm trying to figure out where my mail application is. I'm trying to figure out how the search bar comes up so I can actually search for that. I'm typing in the name of a parent that I know that in the same class that, that's how you get someone to think out loud. Because you want to understand why they're making certain decisions. So that's a big part of Think Out Loud. It's a very cool technique because you will discover a lot about what someone's doing. So some of you did that in the very first design assignment. So it'll be hopefully something you'll bring into your practice. So when you show someone, because if you show someone your interface and they just sort of kind of poke around on it and they go, that's cool, I like the kind of screen. It's like, it's better if they're doing this Think Out Loud and if you're doing this Wizard of Ozing because you'll get more information. You don't lead the participants, you let them sort of figure things out, and you kind of only answer questions that get stuck for a really long time. And usually have a debrief as part of this because you want them to understand kind of at a larger picture what problems they saw and sort of what the kind of outcome is. And the other thing is just when you're preparing this, thinking about who you're going to select. So for you, many of you are sort of been tasked to pick a certain demographic, so you'll be thinking about who that is and prepare scenarios that make sense. And you can prompt them into a scenario because if you're doing something that's your application is going to a gymnasium to choose your workout, then you have to prompt them like, okay, it's Wednesday, you have a workout, usually at 2:30, and this is that's your sort of how would you get to the gym, or how do you just arrive? What's the first thing you do? These kinds of things. You usually practice running it, of course, like most things with people on your own team, and then you can kind of pre-build the Wizard of Oz parts. Just a couple little tips about it. You want to rehearse everything. You also want to stay enrolled. It's kind of fun. Look, Halloween's coming up, another great Halloween thing. You could be like a, Wizard of Oz user experiment person. Okay, that's a bad example. But you actually can, it's fun to be in that role because the person won't defer to you like, wait, well, what's happening? Like, well, he's the computer or she's the computer. It's like you have to just talk to the other people. And you just remind them of the rules. This was actually, this Wizard of Oz was actually someone's dissertation in the 80s. And it was actually some investigation that it was not, of course this is reference to Wizard of Oz, but when asked about it, let's see, it was, who is it here? Yeah, John Kelly, it was his dissertation work in the 80s, and he said it was, the Oz part meant offline zero, because as computer scientists we come up with really kind of wacky explanations for things. So offline zero because you were offline doing this, so it was like this weird offline zero. So there you go. We can't help ourselves sometimes. You record the critical incidents that occur, so this is really good because you can see instantly when someone they get stuck. You want to note that they suddenly understood something differently, or if they said that's cool, that's useful. So the things that are kind of outliers, as well as the kind of everyday actions. And then the idea is that this is part of your iterative design, so you can actually think through. You can do the same thing you did somewhat with sort of here's evaluation. You can go back and say, let's do sort of severity rating of the problems that we found through this Think Out Loud and through this Wizard of Oz, and it improves the design. And it's very low cost, right? How much time does it take to make a couple of these designs? These pictures were people sitting there like cutting and gluing and drawing, but there are so many software tools now to let you mock up interfaces in minutes. And it's helpful still to have sometimes on paper, but you can also run them. They have a lot of things, as you know, you can run them on a screen. And it's all about the kind of different fidelity that you have. All right. Okay, that's it. Finishing early, I don't have any other stuff. So if you want, actually, I'm going to tell you, this is a really good moment to actually spend some time with your group if they're here, talking about the different project designs you have. Because I'm going to put out something on Piazza. We need to have the groups really shuffle it up and go for that slightly more aggressive design. You're going to have more fun with it, and it's also going to be something that'll make a better portfolio piece. And Next week we do kind of some information, like I said, on doing how to do user studies and how to analyze the data coming out of user studies. And then we went through, have a midterm, and then we move into the second kind of part of the class. Questions? Yeah? Okay. Remember, I want to think about also, you have, and then soon after that, you have like Halloween costumes to worry about. Everything's coming at one time. All right, have fun with your watches. We'll talk about them, see what you guys think about them in a couple weeks. All right, have a good weekend. Enjoy section, because the section they're going to go over some really critical stuff, so please go.